Now let's turn our attention to a brief review of WAS on z/OS. We wish to stress that every element of the earlier topology design we showed for WAS applies to WAS z/OS as well. And we wish to stress that every concept of the application server applies to WAS z/OS too. And it's very important you understand that every single open standard supported by WebSphere Application Server on the other platforms is supported in exactly the same way on WAS z/OS. The focus we'll take is really at this lower layer, below the open standard interface line. This is where WAS z/OS parts company with the other platforms and starts to exploit specific elements of the z/OS platform. Let's look at the application server. All the concepts shown earlier apply, but WAS z/OS does something unique. It splits the model into two JVMs. So picture in your mind the single JVM application server we showed you before. This is what's used for Windows, AIX, and Linux. The first of two WAS z/OS JVMs we'll explore is called the controller region. The Java code in this JVM is entirely infrastructure code, or what we like to call plumbing code. Your applications don't run here. The controller hosts the listener ports, but more importantly, the controller does what's known as WLM classification. The details of the WLM classification and the WLM work queues is something we'll cover in more detail in a separate video unit. The second JVM we'll illustrate is called the servant region. This is where your application runs. Here's a departure from the other platforms. Multiple servant regions are supported behind a single controller region. This provides a kind of vertical scaling for workload. This also allows differential system resources based on workload classification. But that's a topic for another video unit. Finally, z/OS WLM sits between the controller and the servants and acts as a kind of intermediary. Again, many more details are coming on the specifics of this. But for now, understand this. z/OS has a great many valuable attributes, and WAS z/OS is all about exploiting those attributes. To maintain the important WAS is WAS theme, it's critical you understand that at the open standard interface level and above, WAS z/OS is the same as any other platform. The differentiation occurs below that open standard line. Let's review at a high level some of the z/OS specific differentiator items. The first is something we call WOLA, which is short for WebSphere Optimized Local Adapters. This is a cross-memory communications mechanism that strips away all the overhead of networking protocols and messaging serialization and passes messages back and forth between WAS and external address spaces using the z/OS cross-memory services. The next is the use of z/OS System Management Facility, or SMF for short. But further, with WAS z/OS version 7, a brand new SMF record was architected and delivered. This is the SMF 120.9 record. This provides useful request-based information at a very low system overhead cost. Fricka is a function of the TCP stack on z/OS. It's a very low-level caching capability in the TCP stack. What WAS z/OS did in v7 was to extend the all-platform WAS Dynacache function so it could use the z/OS TCP Fricka function as an extension to Dynacache. The applications are unaware Fricka is used. They see only the Dynacache interface. But WAS z/OS pushes the cached objects even lower. Fricka is a remarkably efficient caching mechanism because it is so low level. Thread hang recovery is a mechanism designed to delay or avoid altogether the dreaded JVM recycle due to hung JVM threads. There are several different mechanisms used by this new function to avoid or delay a JVM recycle. For now, it's sufficient to say that given how disruptive recycling a JVM may be, it's best to avoid it if possible. That's what the new thread hang recovery function does. The last item is called DCS over XCF. WAS on all platforms has a heartbeat and signaling mechanism that keeps the WAS system aware of its environment. By default, that signaling is done over TCP. The z/OS Parallel Sysplex environment offers a very efficient signaling transport called Cross-System Coupling Facility, or XCF for short. This new feature takes the DCS signaling and moves it off TCP and onto XCF. The result is a lower CPU usage, particularly for larger WAS topologies. We barely scratched the surface of these ZDiff items. WOLA in particular is covered in considerable detail under the WP101490 document at ibm.com/support/techdocs. We even have YouTube videos on WOLA, just like this YouTube video on WAS itself. The key message we wish to leave you with is that WAS-ZOS is designed to take advantage of the valuable attributes of the ZOS platform. It exploits the platform.